Welcome, fellow chemists, to part 2 on the nomenclature of alkanes, where cycloalkanes, halides, and ethers will be introduced. We will start with the cycloalkanes, and the ring structures that are present are the parent hydrocarbon, even if a substituent has more carbon atoms. Things do get more complicated if we start involving non-carbon atoms, but for now this will apply for simple cycloalkanes with alkyl substituents. So let's take a look at the molecule on the screen. The ring structure on the left contains 5 carbons, which is going to be called cyclopentane. The chain, which contains 6 carbons, will be called hexane. But since it is the substituent on this molecule, we now call it hexyl. So the molecule is named hexyl cyclopentane. Okay, so we just saw the rule applied where the substituent contains more carbon atoms than the ring structure. So let's take another look at the same rule applied, but where the ring structure is larger than its substituent. On this molecule, the ring itself contains 6 carbon atoms, which we will call cyclohexane, and the small chain only has 3 carbons, which is normally propane. However, since it is a substituent on this molecule, we call it propyl. Putting everything together, we get propyl cyclohexane, and we don't need a location number as propyl is the only substituent on this molecule. However, if there are 2 substituents on a ring, they are cited alphabetically and position 1 goes to the first one named. This means we check the clockwise and anti-clockwise directions in order to determine the other number. So with that brief description of the rule, why not give naming this molecule a go? We have the same ring structure from before, cyclohexane, and the 2 substituents are ethyl and methyl, so we know what's going to come first alphabetically. So we have to number from the location of the ethyl group, which we give it the 1, and clockwise from that position, the methyl group is 6. If we try the anti-clockwise direction, the ethyl group again starts at number 1, and the methyl group is at position 2. So we're obviously going to choose the anti-clockwise locations. So putting everything together to name the molecule, we get 1 ethyl, 2 methyl, cyclohexane. If there are more than 2 substituents on the ring, then we want to give location 1 to the position where the next substituent has the smallest possible number. This is exactly what we learned in part 1, rule 4, except now we have a cycloalkane instead of a chain. Given that prior knowledge, can you come up with the name of the molecule? Cyclohexane features once again, and the 3 substituents are methyl, butyl, and propyl. With so many substituents, finding the smallest numbering can be a bit difficult, but if you can find a neighboring 1-2 or 1-3 position, start there. Choosing the 1-2 option and going clockwise from the butyl, we get 1, 2, and 5. Switching and going anti-clockwise from the propyl, we get 1, 2, and 4. So we choose the anti-clockwise locations for the numbering of the locations of this molecule. Now that we have everything identified, we can put it all together and generate the name 2 butyl, 4 methyl, 1 propyl cyclohexane. Finally, we encounter atoms that are not carbon or hydrogen. The halides are named as substituents, and they go by the names fluoro, chloro, bromo, and iodo. Since they follow the same rules we have already seen, do you think you can name the molecule on the screen? The first order of business, as usual, is to name our parent hydrocarbon, which is octane. Then we want to identify our substituents, which are methyl and bromine. Since we have 2 bromines, we need to use the numerical prefix di. Now we want to find their locations, and starting from the left, we get a 3 for the methyl group, and a 6 and a 6 for our 2 bromines. Doing the same thing from the right, we get a 3 and a 3 for our 2 bromines, and a 6 for our methyl group. Since we choose the smaller numbers we can, we'll pick the 3, 3, 6 from the right. With everything identified, we can generate the name of this molecule, which is 3,3-dibromo 6-methyl octane. Ethers are the first compound we are naming containing oxygen, and while smaller ethers often go by common names, this video will demonstrate the IUPAC system. the ether group is named with the alkyl prefix plus oxy. Even though we are just seeing oxygen for the first time, give it a go naming the molecule on the screen. As always, identify the parent hydrocarbon first, which in this case is hexane. We have an ethyl substituent on the parent, and on the right side we have the ether itself, composed of an ethyl, or eth, and the oxygen, oxy. Since our ether is on the right side of our parent hydrocarbon, we start our numbering from there with the location 1, and the ethyl group is location 3. With our substituents and locations identified, we can put the name of this molecule together: 1 ethoxy, 3 ethyl hexane. To briefly summarize all these rules, first, the ring is the parent hydrocarbon even if a substituent contains more carbons. You name a lone substituent before the parent ring, but you do not give it a number for its location. With 2 substituents on the ring, the first one cited is given the location 1, and the other substituent receives the lowest possible number. With 3 or more substituents, cite them alphabetically and number them in such a manner to give them the lowest possible set of numbers. Halides are treated as substituents, and so all prior rules apply to them. And ethers are named as the alkyl prefix plus oxy. They are otherwise treated as substituents, so apply the prior rules. In part 3, we will conclude the nomenclature of alkanes with the alcohols and amines. Thank you very much for watching. If you enjoyed this video, please like and subscribe as I have more in development. As I have done before, let me take a moment to recommend to you a couple of wonderful science channels in SciShow and SciShow Space. If you want to be kept up to date on recent scientific research and developments both here on Earth and beyond, these are the channels for you. You will find links to both channels and websites in the description. But before you visit their excellent channels, here are links to 2 of my previous videos on the alkanes. The first is the prior video on alkane naming in case you have not seen it yet, and the other is one way that they can react, a process known as radical substitution. Please feel free to get in touch with me via email, social media, or if you would like, make a request in the comments.